Hello, this is Mrs. Neill, and this is lesson number 18, the 45, 45, 90 degree triangle. All right, here's our 45, 45, 90 degree triangle. It has a 45 degree angle here and a 45 degree angle here. And then this is the right angle, that's 90 degrees. So notice if you've got two angles that are congruent, remember from isosceles triangle, if you have two angles congruent, you're going to have two sides congruent. So your legs are going to be the same length in a 45, 45, 90, always. And your hypotenuse is, remember, it's always opposite the right angle. So that is a setup for the 45, 45, 90. When you have 45, 45, 90, here's a theorem. Stop the video if you need to stop and write this down if you need more time. The theorem says in a 45, 45, 90 triangle, the hypotenuse is square root of 2 times as long as a leg. Since these two legs are the same value, they're always going to be the same numerical value. The hypotenuse is just square root of 2 times longer. So whatever you get right here, multiply by the square root of 2. So with that in mind, let's look at a formula. This is a formula for solving a 45, 45, 90 degree triangle. A squared of 2, and that's it. And you're asking yourself, well, why can't I use the Pythagorean theorem to solve for a missing side or a hypotenuse of 45, 45, 90 degree triangle? Well, you sure can, but that's going to take a lot more time. So this is a nice short formula for you to use. If you go on and you take pre-calculus, you will be using this formula a whole lot. So let's learn it right now. So whatever A is, A can be a whole number, it can be 5, it can be a fraction, it can be 1/2, it can actually also be a radical number. It could be 2 square root of 6, and that would be 2 square root of 6 also. So whatever, to find the hypotenuse, you're going to multiply it by square root of 2. Whatever A is, you multiply it by the square root of 2. All right, let's start looking at some examples. Find the hypotenuse of each 45, 45, 90 triangle. Okay, if you notice, this is a leg, and that's a leg. And they are the same value. They're always going to be the same value. Well, here's the hypotenuse. So let's write the formula down again. I want to write A squared of 2. So let's write the formula down on our diagram. A square root of 2. Okay, so if 3 is A, all I need to do right here, instead of an A, I'm going to substitute a 3 in. Okay, so the length of that hypotenuse is 3 square root of 2. Always use an exact value like a radical. You don't want to use a decimal rounded value. So you need to have a radical in your answer for the hypotenuse in this case. Let's write our formula down for this one. A equals 4. Okay, A is the same value here too. Those two sides are equal. And then we have A squared of 2. Okay, what is A? A is 4 right there. So instead of this A, I'm going to put a 4 right there. So the hypotenuse is 4 squared of 2. Okay, let's look here. Got 5 as this side. A is 5. And my formula is A squared of 2. And that's our value for X. So what is A? A is 5. So everywhere I see an A, I'm going to put a 5 there. So I'm going to put a 5 right on top of there. So the hypotenuse is 5 squared of 2. There we go. That's a very basic example. Let's go on. Okay, so now I'm finding the leg. Well, the legs are the same value, so whatever I find for x will be the same value for y. So let's write down our formula. Remember, it's a squared root of 2. So I'm going to just write this down. That's a leg, and this is a squared root of 2. Okay, so a squared root of 2 is 4 square root of 2. So a squared root of 2 is 4 square root of 2. Notice my a and my 4 match up right there. So instead of 4 square root of 2, it's a square root of 2. So my a and my 4 go together. So this is going to be 4, and that's going to be 4. So both of these values are 4. Okay, so now you're given the hypotenuse. Let's find the legs. These two values are going to be the same since it's a 45, 45, 90 triangle. Okay, so our formula is a squared root of 2. Okay, a squared root of 2 is equal to 6 square root of 2. So do you see that the a right here is the 6th value? So right here I can put 6 and put a 6 right there also. So these two are 6. Okay, I will tell you these are very, very basic 45, 45, 90 problems. It does pick up, and you can have a couple of special cases. All right, let's talk about those. Now, if you notice, my leg is 5 square root of 2. It has a radical in it. Like I said a minute ago, a can be any value. It can be a whole number, it can be a fraction, it can be a radical. And whatever I do for my formula, remember, whatever I get for a, the hypotenuse is square root of 2 times as long as whatever this leg is. So let's write the formula down. This is going to be, we know it's 45, 45, 90 because these two sides are congruent. So my formula is a square root of 2. Just write the formula down. Get that much done. So what is a? Remember, a can be anything. So my a happens to be 5 square root of 2. So I need to put that 5 square root of 2 into this a value right there. Don't look at that. Just put this 5 square root of 2 in for a, and then I need to multiply it by square root of 2 to get the length of the hypotenuse. So if a happens to be 5 square root of 2, and I need the hypotenuse, which is a square root of 2, I'm going to put that a right in there. So I've got 5 square root of 2 times the square root of 2. And what does that get me? 5 square root of 4. And what is the square root of 4? 2. So I get 5 times 2, and that's 10. So this answer for the hypotenuse is going to be 10. Notice you've got a hidden radical inside of that number value. So this side is 5 square root of 2. This side is 5 square root of 2 also. And the hypotenuse happens to be 10. I know that looks kind of weird, but your a square root of 2 is 10. That square root of 2 is hidden inside of that value of 10. Okay, that's one special case. There's one more special case. And this one is a little more difficult to understand, but I'll go over it very slowly. And you do need to practice these so that you get them down right. Okay? There's a special case when the hypotenuse is a whole number. If you noticed on that last one, our hypotenuse ended up being a whole number 10, given the legs. Now you're given a hypotenuse and you need to find the legs. All right, let's work this problem. It's going to take a little algebra here. Let's write our formula. A, and then a square root of 2. So 6 happens to equal a square root of 2. I need to solve for a so that I can find the length of these two values. Okay, so I'm going to do a little algebra. A squared root of 2 is equal to 6. Let's solve for a. Let's divide both sides by square root of 2. Cancels out, and I get a equals 6 over square root of 2. Now remember, you cannot have a radical in the denominator. So we're going to have to rationalize the denominator so that we can have a nice answer. So let's take that. Remember, we want to multiply it by a fancy form of 1 in order to rationalize the denominator. What is my denominator? Square root of 2. So it's square root of 2 over square root of 2. Okay, and I get 6 square root of 2. What is square root of 2 times square root of 2? Square root of 4. So I get 6 square root of 2 over 2. Okay, not through yet. I can reduce that because those are both reducible. They're the same kind of number. That's a 1 and that's a 3. So I get 3 square root of 2. Okay, what did I just find? Okay, I found out what a was. A is equal to the 3 square root of 2. So I'm going to come over here, and this number is 3 square root of 2, and this value is 3 square root of 2. I know that looks kind of weird, but if you notice, my 6 had the square root of 2 hidden inside of it. So as a result, we had to find that, and we had to do a little bit of math there to get our numerical value. Now, that took a little bit of work to do. But if you have this scenario where the hypotenuse is a whole number, I've got a shortcut for you. Now, if you need to stop the video and write that down, please do this. Okay, the shortcut says when the hypotenuse is a whole number, see we had 6 right here, then use the following shortcut to find the length of a side. So instead of going through all of this math, let me give you a shortcut. You want to half it, so take this value and half it, and then root it. So look right here. What was this value? It was 6, and I want to take half of it. So divide it by 2, and it's 3. Okay. Now root it. What root do we have with a 45, 45, 90 degree triangle? What's our root? What's our square root? It's the square root of 2. So that's the root we want to use. So I'm going to take 3 now and just say square root of 2. Oh, look, that's what we got right there already. So if you half it and root it, you don't have to go through all the algebra of that. Okay, let's do another one where we half it and root it. And this will be the last example we do for today. So let's say I have, this is 45, 45, 90, and I have a, and I have a, and I have a squared root of 2. And let's say that this is 12. So if you notice, I have a special case. My hypotenuse is a whole number. So I want to do the shortcut. I'm going to take 12, and I want to half it, and I get 6, and then I want to root it. The root we're talking about is the square root of 2. So then I get 6 square root of 2. What did I just find? I do that to find my a value, which is my leg, and that's equal to 6 square root of 2. Okay. That is our last example for today. I'm Mrs. Neill. Thank you for listening.